At some point, I need to get some videos from my. I need to archive a bunch of videos from my phone to my laptop. Well, I could just delete them. I'll do that real quick. Yes. And the point is that I need to make a copy of a video on my phone right now. That way I can zip it. So I can zip it and make a copy. I don't have the storage to do that right now. Then I can send it to my laptop and upload from there. Because I'm going to record the project stuff on my phone, I think. Because it's easier to look at the circuit boards and stuff with my phone camera. So whatever, I'll keep this on here because it's part of work. $60 gigs of large files. Oh my god. Old boxing sparring. Old guitar playing. Can I sort them by date? No. I'll keep the guitar stuff maybe. Old shadow boxing, not needed. So many videos of it. Oh my god. I don't even know what that video is. Clearing out all the old boxing stuff. Keeping guitar, keeping old weightlifting. Wow. Didn't seem like all that much, but 30 gigs. And I can upload this. Oh, fuck it. It's related to this, so whatever, it's fine. Okay. Oh, look at that. Oh my god, I have 40 gigs free now. Holy shit. Alright. Zip a video real quick. Excuse me. There's one. Two. Cool. Phone will do the rest. I have the storage now. Okie doke. It's now time for programming. So, where I was last time. Oof. I'm not gonna complain about my strategy right now. I don't think. I think it makes sense to rehash the shit I was doing last time. Because, like, yesterday, I ran a couple miles in the morning. Because now I'm fucking part of some running group. And then had signed up for a 5K at work after. And then did that. And then hung out there for like another hour or two. Got back. Took the dogs on another run. Then the guy I'm watching's dog, bosses. My boss's dog. And then after taking the dogs out, whatever, got some food, fed the dogs, and then fucking went to bed at 9 o'clock. And I woke up at 7, so I was only awake for 14 hours. It was felt super early. And I woke up dead at 6:30, and then refreshed, but fucking like refreshed from a good ass night of sleep. But I was dead during that sleep for sure. A lot got detoxed. Yo. Hello? Don't the glass? Alright, we're good. So, I'm not gonna screw, like, yesterday I didn't get any programming done. I figured out some cool stuff for my, scent-based things, which is really important, but I need to upload that. So I'm waiting on the files to zip, that way I can ship them over to my laptop, and then edit them there, because I need to edit the files, because I accidentally doxed my address. It's not super important, but I gotta move that video real quick. So I gotta cut the video and then cut a little bit of the middle out, and then boom, or cut a little bit of the middle of the video out, and then have it be just upload them together. Okie doke. So last time we were doing pseudo random number generators, and the problem is if the seed is the same every time, then you're gonna get the same results because they're deterministic. They're static operation or a known predetermined operation operating on an operand. Well, if the operand seed is the same, you're going to get the same result. So, if the seed is set at runtime, we don't want the user to provide the seed. We want there to be some way of randomly, or at least seemingly randomly, generating the seed to generate a unique experience every time the program is run, either without user intervention or no, without user intervention. That way the user opens the executable, and then it's a unique experience each time, or seemingly unique. So, we have our program. We need to include IO stream because we need output to test. Need to output the PRNG results. We also need the random header because we need access to the Mersenne Mersenne sounds cooler. Mersenne twister, uniform Mersenne. So Mersenne twister, uniform in distribution, and we also need to include alphabetical because these are all within the same library. We need chrono because chrono gives us standard. Gives us steady clock. What do we do? Standard chrono steady clock. Yeah. Gives us steady clock. Or, but we're not going to use it because steady clock is unchangeable. Or another one. There's another clock that's more accurate. The ticks are more precise. So like more differences between this time and this time. So like if I wait 0.1 seconds and I measured on this, it'll say, oh, the difference is 0.1 seconds. Something else might be 0.996 seconds. But then something else could be even more simple, 0.995431896. You're like, oh shit, okay, that's way more specific. If I compare the values, I would want to use the most specific, even if it's not necessarily more accurate, just because in different runs the experiences will be more unique because there would be more differences. So the seed will be further away if I use one number versus another. So we need steady clock. Seed the PRNG at runtime. Building unique runtime experience. Okay, so how do I want to do this? What would be a good way of doing this? I don't want to just fuck around with this. I want to make an example. So random numbers. I always tend to think of things in like an RPG game fashion for an example. I was thinking D&D when you're rolling dice to generate or to figure out how much health and how much other, or not health, but how many, what the what the results of what your health rolls are, level up. This would be something that's done multiple times because with that it's like, okay, it's just a die. Roll the fucking die, bro. I mean, I guess you would want it to be like that because then otherwise, if you ran this program every single time you were going to roll your health, if the die was seated the same way every time, then you would get, oh, I rolled a 6. Oh, next time I open the program again. Oh, I rolled a 6. I want it to be at runtime. So it'd be. You do that. That's one answer. What's another answer? For a use case for a PRNG that spits out numbers that we could restrict to a specific range, it's going to spit out big ass 32-bit or 64-bit. Either like 2.15 billion or like 4 quintillion numbers. We use a uniform int distribution, take that number, or rather to take the Mersenne twister and convert its output to be within that range. So if it's die 6, between 1 and 6, every answer. And then we seed the Mersenne twister using steady clock. We convert it to the result type. Turn type of a Mersenne twister. Get whatever the number is of the time. We convert that to be whatever the hell a Mersenne twister is. Which is probably an unsigned int. That's probably what that is, but it seems like you can get the result type and then not have to worry about it, which is kind of cool. Enemies if I think of an enemy encounter, then I have to flesh out the whole enemy experience. Oh, you entered some enemies in room. Oh, it could be there are this many items in a chest. Oh, that made my ass pucker a little bit. Like, I get funny reactions when I have some experiences. Like when I'm thinking about cool jobs that I would want to interview for or want to have. I can't right now because I don't have the skills that somebody would hire me for or to use. Basically, don't meet the recs, but the job is really cool. I'm like, oh shit! I'll just get hyped up. My ass will pucker. The same way. Well, it's not the same way. It's like when I think about a feature that I want, or when I think about something that I want to do, or a goal, or something that's crazy. It's different from the nervousness of an exam or having to brief a bunch of customers in a big public setting at work. I don't really care too much about them. Physiologically, there's a reaction in there, but it's different from this one. Now I'm picturing opening up a chest, and then so it'll be do once. The chest has some number of items, and then we'll set a variable to be however many items are in that chest. Then, well, I could see in the future when we have classes, we could have an item class. Then there'd be all these different versions of it. But then there would be an aspect of the class or a property, I guess, and you could call it is hidden or has been examined or something. It'd be like for a text-based RPG, you'd be like, oh, okay, there's 4 things in the chest. Then you have to take time to examine them one by one to be like, yo, what is this? And maybe some of them are just always examined. You'd be like, oh, okay, there are 2 valuables. One of these one of these. Oh, we could randomly do each one of those. Okay, that could be cool. Oh, I gotta take a shit. Be right back. Oh my god. Sometimes there are consequences. Okay. I was thinking about on the toilet real quick. I was thinking about a perception system, not for this, but for at some point, or just an idea of for like a text-based RPG. You have a perception system. I gotta take these off when I'm thinking. That's why I keep closing my eyes. Oh, it's so much better. Yeah, so much better. Because these are only for reading. That's it, not for looking at the world, not reading. So, a perception system where if the character's perception is a certain level, control flow would look like this. So, well, the control flow, regardless, would look like this. Um, if the level is under, let's say, at level 10, that's when you get, well, you probably want it to be continuous. So you'd have you can have a switch case, maybe. No, because we don't want it to be for each level. Like, like maybe you're like in Kingdom Come Deliverance, you're just some fucking random dude, but then eventually you get brought up into the military for various reasons in this medieval world. And let's say you're assigned to be a scout, and you have to accurately say how many of each enemy type is in the enemy armies. How many infantry, how many this, how many that. In the very beginning, and you're shitty and you have low perception, you guys are going to be able to say, like, yeah, there's a lot of these, all of those. Maybe he couldn't even tell the difference between these and these. So you can have a perception system where, depending on what the level is, it changes how much your level determines what you perceive. Meaning, you can perceive more accurately the number of total troops of each troop, maybe, and you're better able to distinguish between troops. So maybe at a certain threshold, that's when there's a certain threshold where you can start to detect the differences between troops, like differences between, from far away, the armored guys and the unarmored guys. So you can tell people, yeah, they've got like 100 elite-ish soldiers, armored guys, and then 1,000 that aren't, whatever. But before that, maybe you can't tell the difference. So the control flow would look something like, there's a function and it's perceived. So maybe it'd probably just be void. It would output all the stuff. It'd be void, perceive enemies, and then in the parameters, either it would just access a global variable, or you would pass it. Yeah, you could just pass it. You could pass it the global variable, which is the player's perception level, right? Or just the overall level, whatever. Perception level is fine. I think that makes sense. You could have that in a namespace somewhere. And then you'd say, I don't know if you'd want it to be each. Yeah, maybe that's what you do. You say, okay, there's 10 perception switch case. So there's switch, and you put in the perception variable, and there's a perception level, and then you have case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then under each case, there's a break after each one. And the logic for each one would be for perception level 1. You can perceive. Oh, there'd be another parameter. And the other parameter would be what the reality of the troops are. There's some security funky things here, so like, or cheating. So if this is like a public game, someone could maybe, if they got access to the source code, they could see what the reality is. So you'd pass into this function the actual amount of each troop, the actual army. Maybe you have an object and you call it army, and this is one object, or you have a class called army, and it has all these different potential troop types. By default, they're set to 0. Whenever you create an army object, you set each one of them. So there's 10 cavalry, 15 armored guys, and 100 unarmored guys, and then whatever the hell, 50 marauders, whatever the different troops are, 50 archers, etc. And then you'd pass that object into perceive army, something like that. So you'd pass in the character's level, which is a variable that can change. You pass it in. That way, if I need to change it, I can just pass a different number instead of passing in, or instead of having to go into the function itself, take out that variable and put another in. I can just pass the function different. I can just call the function differently. Like maybe later on, I need to do a similar thing without perception. Maybe perception changes to a different ability. Now I just pass that ability, whatever. So you pass in the army and you pass in the perception level, and then switch case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then default. Maybe default does nothing, or default errors out or something, because you shouldn't have a level that's not between 1 and 10. You start at 1. Maybe you start at 0. But for perception 1, you output. There's some random number generator offset. So we determine a number that's like some percentage between 30 and 50, or between, let's say between 20 and 50. I don't know how to make a random number generator that is weighted towards something. These random number generators are random. I would need a number generator that probably skews high. It's like maybe you get a good perception, and then your people are like, "Oh shit, that was really accurate, nice." But more likely, it's probably pretty inaccurate. But maybe we do just random. Maybe that's how good the random number generator is in general. Say, okay, we just set it to be a wider range. Maybe you got it spot on, but it's probably unlikely. So you set it all the way up to like 50% error. So this number is generated, and it's from 0 to 50. Maybe it's from 5 to 50. You're never going to be accurate. Maybe it's 15 to 50. So the most accurate you can be is 15% off. So 85% accurate. And that number generator spits that number out, and then we say, okay, output IC, and then you take whatever the error is, or what would it be? So you'd say like, okay, there's 1,000 infantry, and you'd say 1,000 minus 1,000 times whatever the random number generator or the pseudo random number generator spit out. So if it was 15, then and you were as accurate as you could get, you'd say, okay, whatever general. You'd have logic for the response and all that stuff. I see. Or maybe it spits out this info. You do the perception, and then it tells you what you see, and you tell the general what you see, something like that. And and you try and perceive, so you like choose. Maybe it's multiple choice, and you're like, what are you gonna do now? There's this army coming. You hear the footsteps, whatever, and you pass over the hill and you peek, and then what do? Do you fucking flee instantly or whatever? Or do you try and perceive and you do perceive? Okay, so it passes in whatever the army is, the object, and then your perception level currently. Then switch case determined based on your perception level, and then it'll say you see 1,000 infantry is the reality minus 1,000 infantry times 0.15, or you could say, I guess, times 15 divided by 100, whatever, something like that. That way, you only see 850 troops. You say about 850, or maybe it has to be rounded. Maybe you have some sort of rounding thing where it, I don't know. I don't know how you do a rounding function. But I haven't thought about that. It seems kind of boring, but maybe at some point. So maybe you see like, okay, about 900 troops or something. That'd be really accurate. Let's say it was 45 is the number it spit out. So, or you could just say, oh, you could just say 1 minus the number it spit out. Or so 1 minus whatever number the number generator spit out divided by 100. So it'd be 1 minus 45, which would be 0.55. So 55% times whatever the reality is. So you have this little formula that says, this is how much you're off by. Here's what's really seen. You see the full result of that. So you see 550 troops. They're really 1,000. You say 550. And then maybe there's another generator for whatever, the fucking cavalry or something else. So you call it again for each one. Or you just call it, and maybe the whole thing you're always off by the same percent for each. Maybe that doesn't make sense. Like, it probably makes sense that you underestimate one but overestimate the other. So like, you see about 1,000 troops, and really it's 500 of this and 500 of that, but you thought it was 400 of this and 600 of that. It was more inaccurate. So you call the random number generator, and it's like, okay, you see 550 infantry. You call the random number generator, and it's like, oh, okay, you see 300 archers. It's really 200. You overestimated. And then whatever, something else like this. Yeah, so yeah, maybe you do. Oh, that's probably what you do. Yeah, you make the number generator signed. That way, the formula can make it so you either overestimate or underestimate. Right now, it's always going to be 1 minus a positive number because it's an unsigned result that the number generator spits out, which means you're always going to be underestimating. It's going to be 1 minus a positive number, which will be less than 1. And then multiplying that by the result means you get less than the result. But if it was 1 minus negative result, say it spit out negative 15. 1 minus negative 15 is 1.15 times 1,000 soldiers. Oh shit, you don't see 1,000. That's the reality. You see 1,150. Not the reality. You're overestimating. And then you do that. And then the next switch case, or we go all the way down, and then maybe it's the same random number generator. Oh, you know what? It could actually just be calling the same thing. We'd have just have a function. It would just be called get random number within range, and each time you just pass it the parameter. So maybe for level 1, you're off by between 15 and 50%, and then it's between 14 and 40%. Then it goes all the way down until like level 10, and it's like you're really accurate. You're off by like maybe 5% or something. So between 0 and 5%. And each time, each case is just calling that function to get the number to see how much you're off by. Each case calls the same function but passes it how much you're off by. So each case, you define a variable within a case. I think the point was that you define them for the case. Oh, and if that's the case, you could just say in the logic before the switch statement, in perceive error, error minimum, error maximum, and then each case assign the specific values to error. So for case 1, error minimum is 15%, error maximum is 50%, and you call the function and pass in 15 50, pass in error min, error max. But for case 10, error min is 0, error max is 5%. You pass in error min and error max, so 0 and 50, get the results, and boom. You have a perception system that uses a switch case, so that for each level you go up, you get more and more accurate at perceiving things. Maybe in there you also have um, a random number generator for 0 and 1, and that determines whether you are able to discern between two types of enemies. So you say, there's a random number generator. Oh, yeah, and that probably happens. So you probably run that first. You say, okay, there's an army. Does the player distinguish between these types? Figure out all the types that are similar. So let's say the player can either say there's army or there's infantry, either armored or unarmored troops, and is that the only one you get confused by? It's like archers probably look pretty different than others. Whatever. Let's say there's different types. You would run that random number generator, and it would either spit out 1 or 0, true or false, and it would be if it's true, say okay, combine the values of whatever the player sees for elite infantry or armored infantry and unarmored. That way, the player, in this case, because he failed, he doesn't see 300 of this and 300 of that. He just sees 600 because he thinks it's the same. He was not able to discern between the two types. And then you run the switch case, and then it tells you how many. And then maybe you call that multiple times. Okay, you see this many of this, you see this, something like that. But I don't know why I started thinking about that. But just slowly incorporating the things that I've been exposed to and practice with a little into my regular thinking about ways to use them. So, need the Mersenne Twister as a PRNG to use as PRNG. Uniform int distribution to limit the range of the PRNG, or to set the PRNG range, and that's it. And city clock. Okay, so in this case, we could just do. Oh yeah, we were gonna do chest. So you open up a chest. Player opens a chest, and then what is the goal here? The output is say that there are this many of that, and that. Seems like I would want a chest object, all the possible items that could fit. Maybe I say that output all the ones that are there, run a generator, see how many each one there are, and for ones that are 0, we just say that there are none of those, or just only say what's in there. You open up a chest, I don't say there's one piece of bread in there. I don't say there are no level 3 dragon demon swords. There are no level 3 dragon demon armor. There are no, I just say there's only bread. That's it. That's what we don't say what's not in there. We say what's in there, what's present. I don't say, oh, there's not a car in my parking spot. I say there's nothing in the parking spot. It's not that there isn't something. It's that there is nothing. So we say what there is, what exists, what do we see, what do we not what we don't see, not what do we not see. Okay, so in this case we're gonna say player opens up a chest. Okay, and then we have different item types. It'll say this many of this many of this many of this. Trying to decide how to say which items are, or how to determine how many of each item is in a chest, or not how many of each item, but which items are in a chest. So we could say there's a random number, and if it's this, oh, you just do the random number generator for each one, and then you just say if it's 0, you don't say shit. You run a So do you generate the number of how many? You say, oh, you say. Say open player opens chest. Let's see. First, I'll just have a little. Okay, so we can say, and maybe I do this differently, but player sees a chest. Do I talk third person? Do we give a fuck? I'll just feel it out. Player sees a chest. What does the player do? And then, oh, okay. And then we'll say, I also need string. Or we could say, yeah, because I need to extract it. And because there are multiple words in the player response, I can say open. Say open space chest. String for capture player's multi-word response. And we can create the variable now. So we'll say it's a standard string, and it's called player chest choice. Or player, we'll just call it. Oops. Player action, and then standard get line in order to get a whole line of text instead of just getting one character. We'll say standard character input. We're going to ignore white spaces. That way, if there's a white space before that the player entered something else before, it's not captured in this line, even though it's right there in the. And then we'll extract to player action. And then we'll say if player action is open chest, then all open chest. Everything here should be guys undefined. Cool. Player open chest. All information chest. Prompt player to open chests. Prompt player to open chest. Then store action. Store action. Okay. Or we could just say prompt store player's action. Okay. Open chest, and what do we want open chest to do? Where do I want to store this chest info? It could have a header file, and it could have different items, or we could just each chest has each figured out each time. How many of these? How many of those? How many of those? Or we could say generate a number for this, or this is the random number generator. This is the random number generator. This is the random number generator, and then If it's not 0, then we'll say whatever. If it's not 0, we'll say whatever. If it's not 0, whatever. And then maybe there's a way to do that better. So I just call it 3 times and then pass in maybe that makes sense. So say a header file with the item types. Yeah, so we could say, and those could be known at compile time. So do I want them to be inline? These are included in multiple spots. These definitions, multiple spots, no good. Yeah, we don't want them to be constant because we don't want to change them. Like the options for chests are fucking jewels, tools, or valuables. What would you find in a chest in a dungeon? Junk, valuables, usables. Then you could fix that. Like, oh, okay, usables are those like lockpicks and pieces of rope. Are swords usables? Or are those like weapons, armor, equipment? Now you need equipment. Equipment, usables, and then junk valuables or whatever. So do we want that in a header file? Just to store the names? A header only file? What would be the value of keeping it? I think it makes sense probably to make things inline when possible. To make it so it's only in a header file, not in an implementation file. And in this case, we're not touching it. It's a constant. It seems like you would have that in an inline. So let's try that. Okay, and we call it chest items. Do a little header file, if not, or header guard, sorry, if not defined. Chest items, define chest items, and if in this little preprocessor conditional direct, then we'll say namespace chest items, and then we'll say inline const expression. Are there const expression standard strings? I don't know. I don't remember. We'll find out though. Because we are using C++20. Yeah, it's right here. Standard string, there's an inline standard string, and then we'll call it, well, yeah, I think maybe it gives a compiler error here. We'll just call it test. Okay, we cool? Seems like we're cool. I mean, it seems like the header file would namespace standard has no member for string. Oh, sorry. Oh, wait, because I haven't included that. So this will be transitively included. String for that. So we need string here. We could get that somewhere else. We could say get player action, and then yeah, that probably makes sense. We could say, let's go ahead and do this real fast. So we'll do say header file player actions, same shit as usual. If not defined, player actions, define player actions, and if namespace player actions, then we'll say what are we doing here? This is cool, but we want to return string. We could say it's a string view, return string view, and then store this somewhere else. We could say return. Okay, so this needs string view. String view. And then we'll say, but it also needs standard string. And then we return a string view. I think we could do that. So we need standard string to capture or to store player multi-word input or action. And then need standard string view to pass a reference to or to pass a view to strings without copying strings. String action without copy. It gets copied. Okay. All right, so we need a string, so we're just gonna copy this shit here. So we're gonna say, okay, what does the player do? And then we'll do this. And right here, we'll say, store player action, whatever. And then right here, oh, this is player action. So this should be, get player action. Hold on. Oh, this is the function. Hold on. Oh wait, no, hold on. Wait. Hold it. So this needs to be a function, and what does this function do? It's called getPlayerAction. So it returns a string view. GetPlayerAction. Just go. Oh, oops, sorry. Standard string view. GetPlayerAction. And it doesn't take any parameters. Okay. And then we need an implementation file, and we'll call it player actions. Include player actions. Nope, not in main. Namespace, player actions. We'll just copy this over. And then in main, we'll take this. Okay. So we've already included standard string and string view here. Each of these has its own header guard, so it's okay that it gets included like this. Because this guy's going to get included later in the main, and it already has string, so there'd be multiple definitions. Because the header guards, it's going to see, oh shit, string's included here. Well, it's actually going to see that it's included here first, and then it's not going to. Which means I could take this out knowing that it's already included. Eventually, I get to crazier shit. When I'm making shit, I'm just going to put what it needs, and then I'm going to include other stuff. And maybe the stuff that it needs is in there twice, but because I've made the header guard smart, I don't think I need to remove this and then make a note somewhere. Oh, by the way, transitively included here. That's why string isn't in here. Because otherwise someone will read this and be like, okay, you have chrono, input, output, random. How the fuck do you have a string in here, bro? Maybe you don't. Maybe you actually don't. So far, it doesn't look like we need it, so maybe we remove it. Okay. So we need a string in a string view. We have this. We've got string view already here. We're going to say and string. Player action. So we're going to say, okay, player action. And standard get line. And store it into player action. And then turn. I think it's able to convert from a string to a string view. So we can pass player act. If we return player action, it's going to return a string view to player action. Works. Okay, so get string player action from player and return view to it. Turn player action. Oh, this needs input and output too. Now is it cool? Yeah. Standard get line. IO string. At least that. I don't know about the white space part. Excuse me. See what's up. Only issues so far are in main. Seems okay. Cool. We return a view to this. Okay. And then here we'll say it include player actions. Include player actions. Okay, please. What the fuck is happening here? Oh, sorry. It's not. It's user defined. player actions, .h. Are we good? I hate that it, like right now, why isn't it autofilling? I don't understand. Okay, and here we're gonna do player actions, get player action. So if I'm returning a view, I don't want to return a standard string. I just want to, like, if I just return a standard string, hold on. Oh god, do I have to make a fucking standard string in order to check this? Find out. Let's see. And replace this with open chest. Where's the issue here? 11? Why not? Oh, motherfucker. I need arrow keys on this. Maybe I... Cool. Alright, now what? 6? Oh, this is player action. Issue here. Oh, hold on. Standard string. Oh, here we go. So, but what if we change this to string view? Are we now okay? Okay, we're okay now. And the reason was all because I was comparing a fucking constant character, these guys, or yeah, I mean a constant C-style string, to a fucking function pointer. There it is. Constant character. Ah, I didn't read this part, dude. There's this symbol. Standard string view pointer, or so like here's a function. Point, I think this is shorthand for a function. So if we say this is a, like if we say standard string, it looks like this is a pointer to a standard string returning function. Right there. So, but now we're good because I have actually called the function, not been stupid anymore. Okay, don't have open chest yet, but now we can get the player's action and then check. All right, here we go. So we're saying player chest, and then we can have this in some big script of all the things that happen, and then it calls this. So this doesn't need to be in main, but we'll say that this is the logic in main. Put the logic of the game in main. Cool. Player sees the chest. What does he do? You say if. Let's get the player's action. So get, this should be prompt player to act. Get player's action and check. If opens chest. If player opens chest. Okay. And now we'll open the chest. Okay. And now we could have a function that opens the chest, but say, how do I, can't, isn't it control K C? Do that for now. Okay. I don't think I need player actions right now. We'll say open chest. We have chest items. What do we want in here? So I think we can have inline const expression standard string. So we'll say, and maybe we have it be a string view. How does that work? If I just make a standard string, like if I make a variable and it's called a standard string view. I don't think I do. I think, what happens if I do that? It's cool. Wait, this doesn't even include standard string yet, bro. What? What does it even think this is? This is the name, the identifier. qualifier, qualifier. What the fuck is this? I don't even know. So if we say string view, it's cool. What if we say string? We know that that's cool. Bro, it's compiling instantly. Holy shit. Okay. Cool. So if I create a standard string and then I have it look at it, doesn't it mean that it's creating a standard string somewhere? This is a standard string created in this file. Or the namespace is in here. The namespace is somewhere. Hold on. How does this work? Namespace is weirding me out. The namespace is in global name. So namespace, it's user defined as within the global namespace. If I include it in here, and then I include it somewhere else, where is it stored? Seems like it'll create it somewhere here, and then tell everywhere else to look here. So, okay, we'll leave it like this. I'll leave it like this and see if it's weird. We're gonna do standard string view. That way I'm not passing around a whole big ass expensive standard string. And we're gonna call this, I wish this could be an array. I don't know how those work yet. So we'll say chests can have junk, or tests can have chest junk. Do I need these to be like this? How much junk? Or can I just call it in the function itself save? I was thinking either I could have it in the logic and in main say output what's in the chest. How much junk? Call it and then pass it junk. There's this much junk. Call it for this. Call for this. Call for this. That's repeatedly calling the thing instead of just. I mean, maybe that's better, but maybe it's good to just call the thing once and then it outputs all the possible things. So there's this much junk. This much this. This much this. I feel like maybe it makes sense to do chest junk and then we'll call it junk. And then we can. Okay. We'll call it chest valuables, chest junk, valuables, usables, then equipment. Or would that just be same thing? Stuff I want to sell, stuff I want to use, and stuff that's useless. I think that's it. There's equipment. There is. Like, does it make sense to store these here? Or would it just make sense to put that in a function? I feel like right now this isn't justified enough to exist. I'll make it later. Cut first. Needed. Re-add. It's cool. Far, this is okay. So it would get input. It would say, hey, open chest. And if, all right, we do this. So now we'll have in player actions again. Then we'll need to update the header file for declare properly. We'll say void open chest, void open chest. Okay. Doesn't do shit yet. Maybe. So I'm gonna open a chest. And we want the time every time we open the program to open the chest. Let's see if it's this, if it's that open chest, and then we'll just do a null statement. Else, we'll output player passes chest by, pass it by, or player ignores chest. Cool. All right, and now we need to figure out what this part is. So if we build it real quick, and then we say, oh, okay, nothing. Player ignores chest. If we say, oh, open chest, ignores chest. So say this, or this. That, or it's open chest. Then it's cool. That way we can do, oops, A is not known. Open chest. And then it doesn't do anything. All right. Okay, we want to open the chest. We want to say we're gonna need a random number generator and other stuff. So we'll say in the opening chest, we'll say player sees this, this many, this. Trying to see how I want to organize the string shit. Like, if this is 0, like, how do I make it work? Junk, equipment, valuable, and not something else. How do I make it junk? This much equipment, this many valuables. Period. We could say player sees return value junk, comma space, this much that, this much that. And then we could say variable to see something. So like sets see something. I did this before. Check if previous things are true. So does player see something? And at the end we'll say, in each one of these we could in each case, it's not a case, but in each if statement we'll set player sees something to true. Or we could say if player sees something isn't already true, do it. That way instead of overriding it, we're just checking something. It seems like it's easier to evaluate something than actually to write something in memory, maybe. Maybe that's easier. So say we'll output player sees case, and then we'll say int junk count. Int junk count is, and then we'll initialize it to be something. Should I comment this out? So there's junk count. Let's do that. Cool. So there's junk count, and initialize it to be return value of whatever, of the number generator. And then why is it doing this? Don't know. All right, we're good. Junk count, and then if Junk count isn't nothing. Or, oh, sorry. If it is greater than 0, or if it's not 0, say if it's greater than 0, just in case we get a negative number somehow. If it's greater than 0, then we will output player sees, and we'll have bool player sees, or hold on, bool chest, bool is chest empty. If the junk count is not 0, alright, fuck this comment stuff now. So we got output junk contents, determine and output junk contents. If the junk count is greater than 0, or we could say item count. It feels like there's a way to automate this. I could just call the function the same way, but then just pass it a different thing. I'll make it this way and then test. Because we'd want different numbers and then to output the different numbers. Yeah, it seems like what we would do is this is how we would want to do it. Or we could say we'd either need arrays. So we need array, and then there's 0, 1, and 2. And those are or 0, 1, 0, 1, 2, 3. Those are the 4 indices for chests. Either have junk, valuable, equipment. Maybe that's it. Maybe that's all there is. Junk, valuables, and equipment. Okay, 0, 1, 2. And then we set whatever the 0th index to be something. So we say the chest contents array index 0 is, and then we get the return value random generator. And then we do it for equipment, and then we do it for valuables. So junk, valuable, equipment. And then do it for junk. And then if there's any junk, we say that there's that array, that index amount of junk. And if there's any valuables, that index junk, valuable. There's that index equipment. There's that much equipment. Keep adding to the string. So player sees if this guy exists, but this is instead not a new variable, but it's our index of an array. We'll put add this much junk. First, so player sees will output this junk, and then the next call, and if the next call yields this much this, next call this much this, then we return that content, or we set the chest somewhere in memory. That chest exists somewhere. That in memory. That way, if the player then says, "Hey, pick up the whatever," we don't have to generate it every time. We actually those values are stored somewhere. So those values need to be stored somewhere. Maybe in memory we have all the chests, all the different possible chests. Maybe we have a dynamic way of creating new chests. They exist. That way, like if a player doesn't open a chest, you don't need to store what it has. Meantime, though, I need unique variables. I don't have a way of storing all of these in one. Maybe this is it's probably not the ideal way of writing junk count, and we initialize it to return value of the random. If junk count is greater than 0, then output junk count three junk. Okay. So we'll say junk. Yeah, there's a way of automating this, sure. But I want to store all these values. I don't want to just say like there's a way of having a function output each one of the things. So we pass it junk, pass it something else, and pass it something else. Excuse me. But then it needs to return both of those things. It needs to you could pass the function junk, then it says this much junk. Then we could say if that much. The function would be spitting out a number, and it would be outputting junk. I'll just continue this way. Store all the values and hard stuff. This much junk. Let's build and see. Oh. 9. Oh, they're both warning. What happens if I just do? Oh, weren't we cool earlier? So what? Do you not have an issue if it's? You still have an issue. Oh, but then that was return type. So if we just make that a standard string, and make that a standard string, well, it still points to memory on the stack. Bro, what the fuck are you talking about? Bro. Oh. Oh, hold on. Bro, what the fuck? So, player actions, the namespace isn't closed, and it's pointing to some shit that's somewhere where it shouldn't. Yeah, the point was that I just commented out too far. I included this in my comment. So this guy, chest. Okay, alright. So let's no longer. No, God, bro. How do I decomment all this? Do I just have to fucking undo? Oh, bro. Now what are you saying, bro? So we're cool. Okay. I'll put junk. Then next we'll have valuable count. If valuable count is greater than 0, then we don't put this here. Flatten that. Do here though. Here we go. Say if there's junk, if junk count is greater than 0, then we need to output comma space. That way we know that junk was here, and then we put a comma space. And then we'll put valuable count. Is that? Then output valuable count, valuable junk, and there's value. And then lastly we'll say and equipment count. If equipment count is 0, scope so that we can say if valuable count is greater than 0, we need to output comma space, and then output equipment count, equipment. This many, 5 equipment. Good. And at the end of all of that, period. Period and end. One warning. We take void chest all the way down to here. Okay. But then if we get player action, would open chest. Why? Oh, bro. Has input output. This is getting it, returning it. We're returning a string view. So what if we said standard string view? Same shit? Because getLine can't extract to location that something pointing to. It needs to actually extract spot. Maybe. Is chest empty? Oh. You need that? Something. Oh. That is weird. So if why does one warning go away? Or does the warning get higher priority because of this? I think there are different warning levels here. So it's one error. Like if we had, what if we had another here? What if we had, just have another one of these here. Would there be 2? No. 2 warnings, and they're both treated as error. It only says one error, and it's that warnings are being treated as errors. In this case, this is a warning, but it's only this guy that is actually being treated as an error. So if we remedy is just empty, then the other warning, oh, here it is there, but it's not treated as an error. One down. Warning? Warning's there. Interesting. Okay. Points to memory allocated on the stack. Odd. Okay. Let's see. Let's see if I'm doing something wrong right now. Oh, good. All right, doesn't work. Learn. Okay, I'm good to go. Fuck it. Fine. Not stopping me now. Saying get in the action. Return whatever the player said. String. Storing it. Creating it. Not copying though. Passing a pointer to it so we can see where he is. Oh. Problem is. Oh wait. No, it should be fine. Because we're returning a pointer to this guy. Oh, so we're putting a pointer that returns our pointer to a local variable, which gets destroyed after the function call. So we pass it to memory, but then after that call, it's gone. So we've returned it, it's gone, and then control returns to main. So in that case, this guy need to be static, then it's only destroyed later. We could copy it. Have local that local variable next scope. Could have it like that. Have, but we don't want to copy him. In this case, we're returning a view of it. It seems like we're accessing it once. We're saying, okay, let's debug her, see how she's working. Okay. Okay. Alright, so that's nothing. And then open chest. Okay. Now it is open chest. We return. See, okay. We've passed memory that says open chest. This is 0, so open chest. What happened? What happened? Oh, or that. So it's not. Oh, okay, so it found false first. Found false, and then truth later. Okay. So, all right. So same shit. Open chest. It found. Oh shit. That's open chest. And then here, let's check. Hair hanging out. It returned pointer to open chest, but it's saying this is /0. I think that's an end line. It looks like a 0. It doesn't look like an. Definitely not a lowercase. Okay. Go and or oh, it's calling it twice. One point is that getting it? Check. Oh. I would need to make it a variable. Standard string is uh, calling twice. Because like right now, if I call twice, if I do it, open chest. Oh, look, works. Excuse me. Say chest open. Open chest. Oh, chest. Oh, that's fucking scary. Groceries. Huh. So if I say open chest, oh shit, hold on. It's doing if this, that, or is that. It's getting that. Check. It's all true. Then it's running the or and calling it again. And then if I type in lowercase open, wait, what if I say, what if I instead pass same? I think that actually might happen. So right now it's not working. I think it might be doing a string view, local variable that doesn't exist. Instead say chest, shit. It's actually not working. So now this is doing the mobile shit anymore. There's no point. If we say open chest, chest is open. If I say open chest, chest is not open. Didn't match. Call it again. Say open chest, just open. Okay, okay. So now it's actually working. If I make this a standard string view, it's gonna see. It's gonna try and it's gonna get into it. But then this is just gonna. It's gonna return a place to look at something. I'm not gonna. This isn't gonna be a variable. Maybe open chest, mark, open chest, mark, chest, and chest. We're not storing it as a variable. If I instead stored, if I just do, alright, so let's output that to see what happens. Player do, open chest. Oh, it returns all the characters. It's actually returning it so and it's because it's local. If I instead made this static, oh, if I take the static away, free that. Open chest is that. It's printing memory shit. long story short, I'm using a pointer to some shit that doesn't exist anymore instead of making it static. So we don't return a string to you because that's a pointer to a string. Seems like, which means we return that and then it gets killed. We look at the pointer, we get garbage value. So when it checks to see, it's looking and seeing garbage value. So I have to see how I just I thought I had my headset on. Cool. Right, so now this is string 2. Should be long. Let's do this real quick just to see what we see. So step through. What's nothing? Let's say chest. It turn. See chest. Okay, cool. It's a standard string. It exists. Player action is open. Turn a pointer to him. Okay. Oh, he's been destroyed. Now what is there? At this location. Also seeing this part here. I think it's setting the thing to be 0 or something. Like I'm not sure why. It's like it's saying value return this. I think it's saying at this location free value. And it's seeing \0, so that's null. Wait, seeing the last character? Old terminator of a string? I think it's basically just getting fucked up. It's getting messed up, turning a pointer to a thing that never exists here. If this instead is static, make it static and make it live program. Or I don't want to copy it though. So there. Good in here, and then it gets destroyed. I think my groceries. I'll continue in a sec.